CloudDB, shaping your new normal.
Hello, everyone. Welcome to the 2021 APAC Groundbreakers Virtual Tour. This year, our event will be the biggest one ever done, with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 17 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can, because this way the sessions you are registered to, you can watch the replays through the platform until December 30 as many times as you wish. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and your main sponsor, CloudDB. Now for today's session, learn analytics and machine learning with Red Bull Racing. Discover the best race of all times with the hands-on workshop by Matthew Peng. If you have any questions to Matthew and his team during this session, please feel free to use the chat window from live webinar located in your right lower corner of your screen. If you also have any technical issues during the presentation and the hands-on, please feel free to post questions by using the same chat window of live webinar on your right lower corner, and we will try to help you the best we can. Now, without any more further ado, I want to leave you with this amazing hands-on session by Matthew Peng. Matthew, it's all yours.
All right, thanks, Francisco. Hi, good afternoon, everyone. If you are in the Japan time zone, good morning and good evening, right? So thanks for your time for attending this workshop with us today. Today, I'm going to walk through how can you use Oracle Analytics and machine learning to discover the best best race for all times, right? So without further ado, let's proceed with our sections today. All right. So what we're going to do here today is we're going to make this sport, the cramp piece, more interesting, right? So what's the challenge, right? Normally when we watching the race, it's quite hard to tell like whether it's a good race or it's a not so good race, right? So today our purpose is to base on the historical data and to help us to identify what kind of the best race characteristic they have. All right, so these are our agendas for today. For the first part of the sections, we're going to showcase how can you quickly prepare your cloud environment. All right. After we have done that, then we'll do a very quick introductions on all the products that we're going to use today. And then we'll proceed with the hands-on lab in the second part, which is we're going to start loading the data. Then we'll start to do some basic explorations. And then we'll do some advanced explorations. And last but not least, we're going to leverage on our Oracle machine learning model to predict whether in the future race is it going to be an interesting or not so interesting race. All right. Okay. If you are looking at you are attending the workshop today, you are entitled to get a free cloud trials just by scanning the QR code on the bottom, or you can access the short links here, right? Once you click that, it will lead you to the page of preparing a free cloud environment for you. All right. So let me quickly show you what you see. Let's say if I quickly click on this link. Right. So let me share what you will see after you click on the share screen. Okay. All right.
Yeah, your screen is loading, and I can see now a browser of the sign up of Oracle Cloud that's going to be loaded.
Yeah, that's right. So yeah, it gives some time to load, right? So when you click on the link, it will actually direct to a sign up page, right? From there, once you key in your basic informations, eventually you will receive an emails. Then once you click on verify your emails, proceed from there by keying in your additional basic information. You should be able to get a free trial account. Yes, here we are. Right. When you scan the QR code or you click on the shortcut link, you eventually direct you to this sign up page, right? So this is where you proceed to key in your basic information like country, your first and last name, and your emails. You click on I'm not human verifications, then click on verify emails. In a short while, then you will receive an email from Oracle that your cloud environment is ready to proceed to redeem. So you just click the link, then you are good to go to proceed by keying in the additional information that requires. All right. So try now. If you have any problems, just feel free to drop us a message at the chat window on the bottom right corners, right? So right now, what I'm going to show, like after you log in, you get your tenancy up, what you will see, right? Right now, what you look at is like, once you have signed up your free trial account, when you after you log into this account, you'll be able to have a look on this page. This is the main page of our Oracle Cloud infrastructures. All right. So instantly from here, you can see the quick start with all some of the common workload that you might use, right? Like for instance, if you want to do some development, you can use the low-code apps with ADB, right? And we also have some offers that if you want to provision it, then this is the shortcut and so, all right, right. So this is what you see. So the next thing, what we're going to do is there are two things, right? So, all right. Sorry, before I forgot, for the lab today, we're going to follow the instructions from this hands-on lab, right? Okay, this is the URL. If you need the normal URL, maybe just give me a second. Let me have a copy this URL in the chat room. Oh, maybe. Just let me quickly show it on the. All right. So we have done here. All right. This is the where we provisions our free account. All right. So after you have provisions account, please come to the shortcut link here so that you can direct to the hands-on lab instructions which I shown earlier. All right. So for the first step, we're going to provision the cloud analytics services and also the autonomous data warehouse, which is our database. All right. So before we proceed with the lab, let me quickly explain what is machine learning is going to help us in this case, right? As we all know that machine learning is a very common topic nowadays. All right. So the main purpose of machine learning exists is to help us to discover the hidden pattern sit within our data, right? Because right now we know that because of our maturity of our technologies, the data that we generating over the years and days is become more and more gigantic, right? So if you compare 10, 20 years ago when we do the data discovery, today when we want to do a better data discovery, eventually the task has become more difficult. That's why in some of the cases, we will rely on the machine learning to help us to discover some of the new data patterns, some data that we never discovered before. Right, just for a quick example, let's say today I have a data of a sales versus my size square, right? So these are the data I have in my historical system. So how machine learning can help me in that? So if I want to find the correlations, yeah, maybe from the eyeball checking, I know that the more size that my product is, I can sell a better price, right? So, but if without the, let's say, assume that I can't check with eyeballs, so I would rely on the machine learning to help me to do a trendy checking. So that's why I have this line. So this line tell me the same thing. The more size of my products, I can sell at a better price. All right. Yeah. So this is some of the features. Okay. So just now we have saw the sample of the one input. Is the size is correlative with the sales price, right? Assume that I'm running a properties company. Is it? Yeah, maybe size is one of the factors that decide my selling price, right? But as a common sense of about our properties market, we'll know that the same size of the house in the city areas and the same size of the house in the suburban or even rural area can have a lot of difference, right? So that is another use case that what machine learning can help us. We slot in more inputs, especially nowadays when it comes to big data eras, right? All the data we look at is no longer limited to our own internal data, which is talking about sales transaction and so. Sometimes we might put others external data factors. For instance, right? Weather decide my products price, or is weather will decide how well my product selling, right? Or geographical, right? I know my product is selling good, but it's not in all areas. So I want to know in which area that my product can sell better, and what is the buying point of my product. Why the people in those areas that like my product, right? All this we can achieve with machine learning. All right. So let's come back to our hands-on lab today. This is the data that you're going to look at today, right? It's all about the grand piece of data, right? Like we have the data from years 1915 until to this years 2021, and also most the race actually have been scored by a fan page, by the racefan.net, right? So it means like this website or web page like actually is allowed of the F1 fans to put some scoring on the race that have been occurred in the past, right? So we're going to use this kind of data set first. Then we're going to find out what are these elements that will decide the score that given by the fans, right? So this will be the data that we'll be looking at today. All right. So this is our angles we want. So at the end of the workshop, we want to do some sort of prediction. So see whether our machine learning predict the score, is it aligned with the real life scenarios. So this is the end goal that we want to achieve today. All right. So without further ado, let's proceed with our labs today. All right. Oh, sorry, I shared the wrong screen. Yeah, sorry, I shared the wrong screen. Just please give me a moment. All right. So like I said, when you scan on the lab instruction, it will come to this page. This is the lab that we're going to go through today's, right? So there are 6 labs in total that we're going to run in the next maybe next 1.5 hours. Firstly is to provision our analytics cloud, and then followed by we need to provision our autonomous data warehouse. Then after that, we'll start loading the data into the database. Then we start to do some basic data explorations, advanced data explorations, and lastly, you're going to see how can we use the Oracle machine learning model to do our machine learning for this Red Bull racing. All right, without further ado, let's go back to our first lab. Right. So when you reach your main page of our OCI, right, this is what you see, right? The first thing what we need to do is we want to provision a analytic cloud services, right? So for us to do that, you can come to the menus icon on the top left here. Once you select, eventually you can check there are a couple of selections that you have. These are the categories that are available in the OCI, right? So for us to provision the analytics cloud, we will go to the analytics and AI sections, and then you will see there's the analytic cloud services available here. All right, so you click on here, it will lead you to the create instance page for the analytics cloud. Right. According to the instructions, right, once after you log into your analytics cloud, you need to come to this page and you need to create an instance, right? These are the informations that given, right? It tell you like you can create you can create the root compartments, then this is name and description, and these are the settings that you will need to create here. All right. So once you are here, what you will see here is like, firstly, you will see there's a create instance button, right? So click on it. So this is the page that where we create the Oracle Cloud instance. Okay, so if you follow the instructions that, and I just script analysis, and I follow back the descriptions. Right, so then I create a root compartment. All right, just some basic knowledge about compartment. Compartment is a component that for us to define the user access, at the same time the resource limitations for particular group in OCI, right? Take it for example, let's say today I have a group of developer that's supposed to run some pilot project using my cloud environment, right? But because this group of developer, they only require the resources for a time period of time, and they don't really need many resources. Probably they just need a few instances and so, right? So for me as an administrator to have better control on this, so normally I'll create a separate compartment under the root compartment, and then from there I can actually configure who can access to this compartment and what is the user group can do within this compartment. And also at the same time I limited resource. Let's say if I tell the system, the compartment, like, okay, this user of this compartment can only provisions 2 instances, and then the user from that user group can only provision 2. They can't provision more than that. Okay, this is how I do the basic users access control from there. All right. So in the instructions, we've been told that we need to create a compartments in the root, right? And then after that, for the features wise, we will select enterprise analytics, OCPU that we will select in 1, and select license include. Once you're okay, then you just click create. Eventually, after you click the create button, you will see the icon in OECs turn orange. Okay, it means creating. Right, then you have to wait about 10 to 40 minutes before it gets ready. In the interest of time, I already provisioned one cloud analytics with me. Just let me quickly refresh to bring this up. Just give me a second, yeah. So far, if you have any questions, you can feel free to ask in the group. All right. So once your instance is available, you will see there's an instance name listed here. This is my OAC instance that I created earlier, right? So when you click on it, when your OAC is available, right, there is a URL available for you to access to your Oracle Cloud, Oracle Analytics Cloud, right? So you just click here, then it will bring you to the page. Okay. When you see this, this is your main page when you log into your Oracle Analytics Cloud. And you saw that means your Oracle Analytics Cloud have been provisioned successfully. That concludes our lab 1. All right. So let's go to labs 2. In this lab, we're going to provision ADW, Autonomous Data Warehouse. All right. So if you follow instructions that you ask you to come, same thing, you comes to the Oracle Autonomous Data Warehouse, then you create an Autonomous Data Warehouse, right? And then the details have been given. You will need to create again at the root compartments, all right? And then the display name for the, we can just put Red Bull, or if you have any choice of the display name, by all means, you can just use whatever name that you like. Just remember, you just need to remember the name that you created. All right. Okay. So how to go to the autonomous database? Okay, let's go back to our cloud main page. Right. If you want to provision autonomous data warehouse, you can immediately identify there is an option autonomous data warehouse here available on your main screen. All right. So you'll be curious why you'll see there's always free eligible, some in some areas, some's not, right? So this always free is part of the OCI offerings. Like when you want to create autonomous data warehouse, you can actually entitled to select the always free options. All right, we're going to go through that later. All right, so for you to create an autonomous data warehouse, you can either click on here, or if you can't find it for some reason you can't find it here, right? The next thing you can do is like you can come to this menu again, right? When you're home, right, autonomous data warehouse is always features here. You still can't find it, you can come to Oracle database. There is the autonomous data warehouse available at here as well. All right, you will all come to the same place. All right. So again, similarly with what we have seen in the earlier Oracle Analytics Cloud side creation list, this is the list that I created earlier. All right, let's go through how can we actually create an autonomous database. Right, just click here. Right, the first option we choose like always the compartment. Right, the system need to know that this resource or this workload need to be managed under which compartment. Right. For the instructions, we are using the root compartment, and then we will use the Red Bull as a display name. It's a Red Bull database name, also Red Bull. Okay, here you might need to take a pause like to figure out what kind of workload that currently we available in the Oracle Autonomous Database. All right. In nutshell, we have 4 different type of autonomous database, right? The one that we were going to use will be autonomous data warehouse. At the same time, we also have the transactional processing, JSON or FX. All right. So what's the difference between these two? All right. Normally, we will use the data warehouse for reporting purposes. Let's say if my database is mainly for the data warehouse, so that from the data warehouse, I can build a multiple different kind of analytics applications from there, then data warehouse will be the one that highly recommended, right? However, if I have a mixed workload, like let's say my database actually is designed for the mixed workload, means partially of the workload have to handle the application's transactions. But at the same time, I also need to handle the reporting as well. If that is the case, normally we'll use the transactional processing, right? This database, the architecture of the autonomous database is optimized for the transactional processing, especially when you have like some high import applications that currently sit on this database, right? It will highly recommended for you to use this kind of workload. Of course, if your application is mainly a JSON centric, you can choose to use a JSON, or you just want to build the quick Apex, but not so high requirement on DB. There's a Apex options for the ADB as well. All right. So these are the four main different workload available on the autonomous database. Right. So for our workshop today, we're going to use the data warehouse, right? So if you are by default, when your always free options is disabled, right? The minimum that you need to provision for the autonomous database is at least one OCPU and 1 terabyte of storage. However, if you want to try out the always free, you just enable the always free options, right? Then you are not allowed to choose the OCPUs, and you only limited have 20 GB of storage, which is for this lab is more than enough, right? If you want decided to go for this, by all means, my guess just continue. All right. So for this one, we are going to stick with 1 OCPU and 1 terabyte for now. All right. So after that, remember, we are going to use the shared infrastructures for this workshop. You don't use the dedicated, because if you use dedicated means before you come to here, there's some more configurations that you need to do. We're not going to cover that in the log workshop today. If you need to find out more information, just please contact us. Right, we are happy to share more with you. All right. So after you have selected shared infrastructures, then you select your DB version. We will stick with 19C for now. And then if you are not using always free, you can specify how many OCPUs and how many storage that you want. But for this case, will remain as one. All right. Here is where you need to key in the password. Okay, admin password. All right. In the instructions, like there's a standard password that been given. Okay, you can use this password if you don't feel want to remember one, right? However, if you felt like this will be a concern for you, just be my guest. You can use any password that you want, right? Just bottom line, you need to remember what password that you have been keying for this admin user, because we're going to use that in the lab later on. All right. So for now, I will just follow back my default password. Okay. Here I will choose secure access from anywhere, right? Which allow me to have external connections from my internet to this database. Okay. And I will select license included. After that, you just click create autonomous DB, wait about a couple of minutes, then your DB should be good to go. All right. Once you create the autonomous database, you will see your autonomous ADW's icon will turn orange while it's creating or provisioning. Right. After it's done, you will see that your ADB will be turned green like this. All right. So again, because of interest of time, I have provisions my DB here. After your DB, your database is provisioned, this is what you see. All right. So you will see there are a couple of options that you have. Firstly is database action, database connection, some performance hub for you to analyze your database performance, and service console. We're not going to go through all of this, but somewhere along the lab, we are going to use some of the options here. All right. So that concludes our lab 2, which is provisioning the autonomous database. All right, let's go to lab 3. In this lab 3, you are required to download some of the data available online, right? So when you expand the task, right? Okay. So in this lab, you are required to go into the autonomous data warehouse that which you built in your lab tools earlier. All right. Click on that, and then you will need to use the data actions features available on the autonomous database, right? Here, there are a couple of things that you need to download. Firstly, you will need to download the repo created user.sql. All right. This is the SQL file that to create the, let me quickly bring this up, right? Okay. So this is how the SQL script going to look like. In this script, there are two activities that it will do. Right. Firstly, the first part of the script is to create a new user called F1, and then granting the user use some of the essential user right to the F1 users. Right. And then after that, you'll create all the necessary data table that required for the lab here. Just give me a second. I online stream. Apologize because some interruptions. All right. I apologize. All right. Okay. Like I say, the main part of this script will have handled mainly two things. Firstly, is to create the users that required for the hands-on lab, and the secondly, we'll create all the data table that require for this hands-on lab as well. All right. So at this moment, you don't have to do anything. First, what you need to do is you need to come to your autonomous DB. When your autonomous DB is done provisioning, you can see there's a database action here. You just click on here. Then eventually we'll have you'll plot another new page that have all the features that you need. So first thing we will need to do is to execute the SQL script, right? So if you have all the script downloaded here, right, you just need to highlight all, copy, and you come to the SQL workspace workbook here, all right? And you paste all your script here, all right? Then you can have a quick look on how the script gonna looks like. If you got nothing to admit, okay, please don't change the script. The script work perfectly fine, all right? So once you paste, you can click this run script or F5 button here to execute the script. All right. If you are looking at what I looking at not right now, means your script has been successfully executed, right? And then we are ready to go to the next step. All right. So this step is to run. Once execute, you should be good to go. All right. For the task 2, there are a set of 6 data that you require for you to download and store in your local drive, right? Let's say it's a race data. When you click on race data, eventually you will pop up some sort of download. Please save to your local drive anywhere that you can remember, because next thing what we're going to do is we're going to upload all this data file into our database. All right. So again, because of interest of time, I have all my data downloaded here. So the next thing what I'm going to do is I'm going to load all the data in my autonomous database. All right. So I come back to here. I go back to the database actions main page. All right. All right. Sorry. Before that, I need to log out and log in as my new user. Right. So after you have successfully executed the script, now you should be able to log in as your new user, which is called F1. All right. So the password given is Oracle_1234. So if you don't change the password, you can actually log in with this password, right? Yep, it's exactly the same page that I in my data action for my admin users. All right. So right now, for us to load the data in, we're going to use the functions called data load, right? So once we click the data load, then there's options that we have. We will select load data from the local file, and then after that, we're going to upload. We're going to select all the 6 files that we downloaded earlier, and then after that, we do some amendment. Why we need to do the amendment, I will explain later. Then after that, we will run the actions. All right. Without further ado, let's go through. So for this next action, we're going to use the data load functions here. All right. So firstly, we'll select the load data, and where's my data? Actually, it's the local files that I downloaded earlier, right? So I just click next. Right here, I can drag and drop the file, or I can click select button and go to here. Right, these are the 6 files that I need. I just click open. Right. So from here, what if you are successfully pull the data, you should be seeing something like this. Okay. Right now, we need to do some amendment. Right. So what amendment I'm going to show you later, right? You see there's a edit icon here. I just click on here. Eventually, you'll bring up the page like this. All right. Okay. Then why we need to amend this? Because by default, when we load the data from the data file, right, it will actually default it to the create data options. But remember, the data, all the data that required, we already create in our database earlier, right? So we don't need to create a new table in these scenarios. All we need to do is just need to insert the tables, right? Once you select insert table, right, what the system does is that you're going to find now, going to based on the data type and the table names that we import earlier, right? You're going to find, okay, is there any similar table currently available in our database? If yes, then you return something like this. So if you are seeing this, then you just click OK because you have done for 1, right? So we have completed 1. So now we have to do the same thing for the remaining 5, right? Just take a pause and just do all this. All right. You just probably need a minute of your time just clicking. Remember, when you click edit, select the insert into tables. That is the options that for this lab. All right. All right. Once you have changed all the necessary changes, just click on the run button. So it will take about 3 minutes because I'm using the minimum. So it probably took about 3 minutes to load all the data in. So the data size we're looking at is not really that small. It actually compresses about over 30 million, 30 millions of data. Imagine that 30 million is just like 3 minutes. Eventually, the performance is, for me, is quite satisfied on that. All right. Right. While we're waiting the data to come in, let's quickly go through what we're going to do next. Once your data is loaded, right, let's conclude our lab 3, which is loading the data. Right. For the next part of the workshop, which is lab 4, will be taking some time. This lab will take about approximately about 30 minutes. Okay, what we need to do in this lab is firstly, we will need to go to our analytics cloud, establish a connections to our DB, and then we start to pull some data from DB to the analytics cloud and start to do some of the analysis from there, right? So lab 2 is to adding the data set, and lab 3 will be adding the task 3 will be adding the lab times data set as well. And then after that, we're going to find out what is the worst and best race according to the fans input, right? And then what is the criteria to decide whether this race is a good race or is a bad race. All right. If you have time, you can actually expand all tasks. You can have a look on that while we checking on the file that eventually whether it's done. Okay, it's almost there. Right. So you can have a quick look on the lab also, right? Okay, while we're waiting here, let's do one additional things. Okay, for the next thing, how we going to connect into DB? We're going to require a DB connections here. All right. When I click this DB connection, eventually I will need to download a wallet file for this database. So for me, so once I come here, right, I click download. Okay, this is where you need to key in your admin's password. If you are using the same admin password as I do, then you just Oracle_12345. If you are using your own admin password for this, please key in your admin password before you click the download button. If your password is correct, then eventually it will prompt you a download page. Something like this. All right. Save your wallet file to somewhere that you can remember because we're going to use that later on. All right. Okay. Okay, the data is seems like almost done. All right. So after we download our connections, what we need to do, okay, we will need to come into our Oracle Analytics Cloud. If you forgot how to come in, again, we can always go back to the main menu, which is here. Click on the menus button on the top left corners. Right, go to Analytics and AI, select on the Analytics Cloud. And then you will see your instance is available here. All right. So if you already put it here, you can always come here. This is the first page that you will look in your analytics instance. All right. Sorry, just give me a second. Let's quick check. Okay, now all the files have been loaded in. All right, from here you can actually go and have a quick check on the file, whether all the data is loaded here. So you can come to the SQL worksheet here. All right, so you can just drag and drop your one of the table here, select on the select statement, and then you just execute. All right, eventually, if your data have been loaded successfully, you will see there's some data returned in your tables. When you see this, it means all your data have been already in the database. All right. Okay, let's come back to the analytic instance. So again, if you don't know where to find your analytics instance, always come to the menus here. Go to Analytics and AI. Click on Cloud and Analytics Cloud. Eventually, you lead to this place, right? So if you already provisions or you already created your Analytics Cloud instance, you can check there's a one cloud available here. So you just click here. Eventually, from here you can have a link for your cloud instance, right? Analytics Cloud instance. Then this is the place that you will land. Okay. So for the next lab, what we do is like we're going to establish the connections between this Oracle Analytics Cloud and the autonomous database, right? So to do that is really straightforward. There's a create button available on the top right corners, right? Just click here. There is a connections options here. All right. So you just click here, right? Right. These are the data connectors we Oracle Analytics Cloud supported by default, right? If you are using Autonomous DB, there will be a dedicated autonomous data warehouse connectors available. There's also autonomous transactional processing connectors available. If you are all using traditional Oracle DB, then you can use these Oracle options. On top of that, if you are using Azure Synapse or you're using Apache Hive, Redshift, and others connectors, by default, these are all the connectors supported in the Analytics Cloud. For this lab, we're going to use the autonomous data warehouse. You'll select this. All right. So give it a name. Let's follow back to the instructions. Like, okay, we are here. So in this connection, we're going to name it Rebu. All right. Rebu description, we can skip for now. Okay. This is where you require your wallets. Remember, at the earlier step, we actually asked you guys to download the wallet from the autonomous database, right? So after we download, this is where we need to select the wallet, right? So when you select, navigate to the folders that you store your wallet file. So you select on the wallet _rebu.zip. Open it. The system will read the contents within the zip file, right? So in this case, we can use a medium, right? And then the username will be F1. Password, if you are following the password given in the lab, should be Oracle _1 2 3 4 5. And then you save it. If your credentials is correct and all the information is correct, but you will see there's a green pop-up just now. Connections have been successfully connected, right? Then after that, you can check your connections. It will be available in this area. When you select data, this is the connections. All right. So after you have done the connections, the next thing what we need to do is like we need to create the two data set. Firstly is the race data set, and the secondly will be the lab time data set. All right. So let's go through the task of creating the data set, right? So go back to your Oracle Cloud Analytics. Again, click on the create button. Select the data set. All right. From here, if you realize that your connection is not here, you can always create a new connection by clicking the create connections button available on here. But for this case, we know that we already created the Rebu connection, so we just use the existing one. All right. So after you have successfully connected, you will see all the schema or the tables that currently available in the left-hand corner. So for this case, we're going to append the F1 users, right? We're going to pull out the race data. Okay. What it does after you do the pooling is that firstly the system will go into the DB to get the data, and secondly, like the system will actually do a quick check of what is the contents available within your data itself, and then you'll be able to see some summary visualizations that show you, right? So these are the high level data that available in your data set, right? As I mentioned, the data that we have actually is from years 1915 until years 2021. That's why you see the years 2021 here, right? These are all the race name, right? And then these are the time. Okay, you can have a quick check on the score also. Is now you see the red bar, it means like 77% of data actually is missing. It means that probably only some of the race, like the fan giving the score, right? Not all the race. So it tells you the data availability here. And the score that contains within the score columns here, it actually is like a normal distribution. It means most the score will be like somewhere between 8 until 5, right? Of course, there's sometimes you can have a very good race, there's sometimes you can have a very bad race also, right? So, right, after you've seen this, means you have put the data here. Next thing, what we need to do is like we're going to do some change of the attributes, right? We have done this, right? Right. So what we're going to do next is like we need to change the race table, race ID columns into the attributes. Okay, so let's go back to here, right? When you click on the race, you will see there is a metadata icons available here. You click on that. All right. Okay. From here, you will see some is returned as attribute, some is returned in measures. All right. Let me quick explain. Have a quick explain what is this. All right. When you load data from any data source, regardless is the ADW or Oracle DB, or you have your own Excel spreadsheet, right? When you load the data into the Oracle Analytics Cloud, by default, Oracle Analytics Cloud will identify all the numbers as a measure, because sometimes when we load data, if there's the column is all written in numbers, most likely it's a measures, right? But that's not always the case, because especially like let's say if my race ID actually is in number, but I know that this one is not a measurement because I can't count the race ID. So I can always change it as the attributes. So the attribute, it will be the dimensions for this data set. The data set you will need to will need to segregate or will need to categorize based on the attributes, right? So first thing, we need to change the race ID into attributes. And the secondly, like, okay, we need to change the score calculations method into average. Okay. We know that this score actually is being given by the fans in score by race, but we can't sum it, right? We have to get the average scoring for the race. So we can always change the aggregations method into others. By default, it's sum, but you can change to average or others as well. Okay. Right. After we have done this, we will proceed to save the data set as race, and then we'll proceed to create a second one. All right, just let quickly go into the saving this data set. So just give it name race. All right, when you saw this bar, means your data set have been saved. Then we go back. For every new data set you set, right? If you're at the main page, you click on data, you will know that what kind of data set is currently available in your analytics cloud. All right. So right now we're going to create a second data set, lap time, and we're going to save the lap time as well. All right. So let's quickly, okay. Beside that, you can come here. Actually, there's another shortcut that you just click on the connections red. Boom. Eventually, you'll lead you to this new data set place as well, right? So you just append the F1. Now we need to drag the lap times into the middle. Okay. Right. So when you see this, mean the data is reading the data. So next thing what we need to do is similarly we will need to change the metadata of the lap times tables, right? So in these instructions, we will need to change the race ID, driver's ID, and lap into the attributes. All right, and then we'll save this data set at lap times. All right. So for us to do that, after you have reached this area, you click on the lap times on the bottom, and then you'll lead to a page that where the metadata icon will be pop up here. Yes. So you just click on here. We change the race ID into attributes. We change the driver's ID into attribute as well, and also the lap. After that, we will save this data set as lap time. Okay. So once you're here, right, go back to the main page. Just click refresh. Okay. After we have done this, so the next task that we're going to find the best and the worst race according to the fence. Remember the data that we captured just now, there's some scoring that scored by the fans, right? So now we need to find out how the fans look at which race is the best and which race is the worst, right? Right. So firstly, we will need to go to the data set and we will start to do some visualizations. All right. So to do that, okay, when you are here, right? Okay, how to come to here? Maybe let me go to home again. All right. When you're at home, you click on the data options. Like these are the data that you have created earlier, right? So for this case, we're going to use the race data set, right? Quickly, in order for you to create a worksheet, you can either use the create button here. This is a workbook, or you can just directly click on the data set. Once you click on the data set, eventually the system will create a new workbook for you, right? So when you come to here, the next instructions that what we need to do is like we need to get the score and the name underscore year and create it as a table. All right. So quickly how we do that, you can use the control button on your keyboard. Firstly, you click on the score and then you hold the control key and you click on the name year. And then after that, you just right click, pick visualizations, and you will select the table options, right? So once you did that, then you will see there's a one table created which have score and the year name. All right. We know that most of our data doesn't have score, right? So the next thing what we need to do is we need to do the filter, right? We only want to focus those races that currently have score from the fans, right? For us to do that, it's very simple. You see there's on top of here, like there's a drag here or drop data to add a filters, right? So all we need to do is we just drag the score on the top here, and then we can range the filters. Like let's say I want to starting at 0 and I want to, and at 10, that should be eliminate all the zeros. Yes. So after you have done this filter, you see like your table will reflect it immediately. You will take out all the blank score data. Right now, we only focus on those data that currently have score, right? So how do we find the best, right? When you move your mouse cursor, right, you will see there's a one sorting button for the score high to low and low to high. So in order for to find the best score, we just sort it by high to low. Voila. Now we have the best race. Best race by the fans, which is the 2012 Brazilian Grand Prize. Right? Take that. And then in order for us to get the lowest, similarly, I instead of sorting high to low, now I'm sorting low to high. Right? Okay, which is the lowest score for this, it should be 2020 Abu Dhabi race. Okay, remember these two, 2012 Brazil and 2020 Abu Dhabi. Right, these are the two things we're going to focus on. All right, so now we have identified what's the best and worst race. Right, so we can save the book, save it as all. What's the name? All race overall. All right, so all race overview. Save. All right, so when you go back, so now we will create another worksheet, which is we want to analyze what is the overtake and the DNF, do not finish. Okay, we want to know how many do not finish, right? So in this time, we're going to use the lap time data set. So similarly, we click on the lap time. Okay, after here, okay, firstly, what we need to do is we need to filter. Remember just now that we have identified the best and the worst race, right? The best race will be 2012 Brazilian race, and the worst race will be the 2020 Abu Dhabi race, right? So first thing what we need to do is we can drag the race name on the top. Then after that, from here, we can find like what we need to filter. So firstly, I get the best race, which is 2012. 2012 Brazilian, yeah, here, right? And then the second one I want to filter is 2020 Abu Dhabi. Right, so I have a filter, right? So next thing, what I need to do is I need to create a line chart that to indicate the position change and the driver by the driver reference. So how I do that quickly, I will need in the instruction I will need the lap positions and driver reference. Right, I can either take control to select multiple field keys, right? So what I do is I just select race, hold the control key in my keyboard, I click on positions and driver reference. I right click, I pick a visualizations, then I select line chart. All right, okay. In a split second, you should be able to see your line charts available here, right? But if that's the case, I can't see details by race. So what I need to do next is like go back to the instructions. Like eventually, it asks you to drag the race name into the tallies row. Okay, so we'll do the same thing. We drag the race name into the tallies row. So now you can see how the movement change between the race, right? Okay, right now what you see is on the top is the best race of all time that scored by the fans, and this is the worst race scored by the fans. All right, so you can we tell the difference? Yeah, the best rate we can see there's a lot of line crossing each other, but the worst rate is lesser, right? So this line crossing means there's a change of the position, and the changing of the position is from the beginning until the end is keep changing, right? And on the other hand, the worst rate is like they only have some of the change of position, but towards the end, like everything pretty much fixed, right? So this what it means is like in the best rate, best rate in the fans eye is like all the car racer, right, actually is fighting the positions from the beginning until the end, right? You can see the changing of the position happens quite frequently. Almost every lap what happens, right? But on the other hand, the worst rate is like it's just like flat flat, no much changes on it. So that is probably one of the key element how the fans decide that this is the best race or not. All right. So now we have here, okay, so right now we want to find out what is who did not finish the race, right? So in the instructions, you're going to ask you to focus on the position top 1 to 5, right? To do that, we will use on the filter bar on the top here. What we do is like we will just drag the positions to the top, and then we will only focus on 1 to 5, position 1 and 5. Okay, so how you identify that this is do not finish race? Okay, so let's focus on Hamilton, right? You see Hamilton started with 1 and it go fall back to number 4, then it catching up, but his line stopped here, right, at the lap 54. Then no more Hamilton, right? So what it means, like Hamilton managed to race until the lap 54, but something happened that he have to pull off from the race. So this is where how we identify the do not finish. All right. So after we have identified that, then we just delete this. All right. So next thing, what we want to check is like whether the do not finish will affect the race score or not. So in order for us to do that, we will need to add another data set, which is the race data, into the worksheet here. All right. So by doing that, firstly, okay, when I in the worksheet, you will see there is a plus button here, right? This is where we add a new data set. So you just click add button, add new data set. Click on next race data. And then the system will add the race data into this workbook, right? So you see now your data is available here. So for this case, we need to create, we will need all of this data. So what we do is like you can use the shift button on your keyboard, right? You just click the race ID, you click and hold shift, and you click the last one, then eventually you highlight all the columns here. And then after that, you right click, pick a visualization, then this time we will select the table. Right. So now you have the table for the race for table details table for these two races. All right. So next thing, what you need to do is like you need to check on this. Okay. Compare what is the characteristic for these two races. All right. So again, 22nd is the best race, 2020 is the worst race. So we will need to check how's the positioning like. Okay. You see in the 2012, right, there are 6 drivers that actually do not finish the race, but on the 2020 only 1, right? Eventually we can know that, okay, that might be an element. Then we drill down, okay, this is something interesting. You see there's different. On the top one, let me make it bigger, that's okay. We can have an overview, right? So you see, on the 2012 Brazil race, the overtake positions in total happens 367 times. On the other hand, 2020 it only happens like 79 times. Eventually, that is a very big difference, very big gap comparing these two. So why happen then? Why happen? Why we realize why this overtake happens so frequent? Then when we have a look on the weathers, we know that actually on the 2012 race is actually on the raining day, and the 2020 is the race day. Then that probably explain why, because the road condition is so wet that especially when a high speed racing like F1. So when the road is wet, so it will make the driver have more challenging when they're on the race. So that's why either some are less capable drivers overtake, and then you can overtake back. So eventually I can imagine on this kind of weather conditions, on the 2012, the race is very challenging, right? We don't know who will be the winner until the end, right? So that probably explain why. Okay, that probably explain how the fans can give so high score for the race like this. All right. So after we have identified the possible factors, right now the next thing what we need to do is we will need to create a correlation. But before that, let's save this worksheet first. You can just save it as a race analysis. After we save it, let's go to the next one. So in here, we are going to create a correlations diagram for the race, right? So for us to do that, let's go back to the main page. Give you some time, right? Again, for this task, we're going to come to the race data set, and then we're going to build a scatter plot. And then after that, we're going to build, finally, we're going to build a correlations chart like this, right? So without further ado, let's proceed, right? So while I'm here, I click on the race. Okay, so once I'm here, I will need to select score, overtake, and number of years, right? So let's go to score, overtake positions. Yeah, sorry, that's the one. Yeah, score, overtakes, and the last one will be the name year. Then I can create the scatter plot. All right. I realized that there are different in the instruction. I will need to use the score as a y-axis and then overtake by the x-axis, right? So in order for me to swap play, I can just move to overtake. Eventually, you see there's a swap button, right? You just swap it. Yeah. Now I have the chart. I won. Okay, next thing I can add a statistic. Okay, in OACs, by default, they have some of AI ML that built in the system for us to do some quick statistic, right? So let's say if I want to build a statistic chart from here, right? All I need to do is I can click on the menu icon here, or I can right click anywhere from the chart at statistic, at trend line. Eventually, what the system does is like you're going to analyze your data point and then you plot an average line. So from here, what we see is if the overtake happens more frequently, right? Most likely, the fans will give a high score on that race. Okay. Right. So right now we have done the overtake. We want to do the similar thing for the do not finish, right? So I can always build a new chart here, but I'm lazy, right? Let's say I want to minimize my effort. I can just come right click, go to edit. There is a duplicate visualizations option here, right? So I just duplicate here. So right now, what I need to do is I just replace the overtake with the do not finish count, all right? So let's say I select this, I just select do not finish count, replaced by overtake. So now I have a trend. I have a similar chart for the do not finish also, right? So if do not finish is more than if the fans will give high score, well, not quite unlikely, yeah, because you see the high score here. Even all the driver finish the race, sometimes the fans might give him the high score as well. So because of this now, we need to we need to build a new canvas to find the correlations. All right. So what we need to do is next thing we will create a new canvas. Oh, we don't need, right? Yeah, I changed my mind. Okay. So next thing, what we need to do is like we're going to use the score to not finish count, or do not finish due to accident and overtake position to find the correlations between these four, right? So very simple. I can select the score from my tables. Then I use the control key again. Click on the do not finish count, do not due to accident and overtake. And then I right click, pick a visualization. This time I will select on the correlations matrix. So now what I'm looking at, what is this chart telling me, right? We are focused on score because we want to find the correlation on the score, right? So in here is tell me that if I want to get high score, most likely might need the overtakes happen more frequently, and then only followed by the do not finish count. This one due to car accident or not really matters, right? So the most important is this point. So that is how we analyze on the correlations between the data. All right. So after we've done this, okay, then we need to create a new canvas. We want to find the correlations between the weather also, right? So for us to do that, now we'll create a new canvas, right? Oracle Cloud Analytics is a generic BI engine, right? So by default, we don't limit how many canvas you can build, right? You can build as many as you want, and we don't limit that, all right? Okay, so for this case, like this lab, we're going to use the score weather wet, and we build, and also the uname, we will build a visualizations, which is the candle chart, right? So for us to do that, so we're going to use a score weather wet and here. Then we right click, pick visualizations. We will choose the plot, also known as candle chart. Okay, so right now we have our box plot, but it's not something what I want. So in the instructions that given, I will need to pull the name into the details. So very simple, I just pull the name into the detail box here. Yep, so now I have my chart. So what this chart tell me is, if the weather is wet, right, most likely the fans will give me a high score because it makes the race more challenging, and the fans like challenging race, right? Right. These are the finding that we would like to plot here. So until now, then we can save our worksheet as correlations. Correlations. Okay, so that's conclude our lab 4. Right. So now we go to lab 5 bonus. Okay, so we have done like how the fans are giving the score from the race, right? So right now what we want to see is like, how is there any comeback score within a hidden pattern that we see earlier, right? So in this task, in this lab, we're going to do the 4 tasks. One, you want to see is there anyone that making a comeback after the fall at the behind position, while are they be able to make it comeback, right? And then how many of them making the pit stop, and the ghost car concept will be like, let's say if I plot it the entire rate at the average speed, like how many driver actually surpass the average, how many below, right? Okay, these are the advanced analytics that we want to explore, right? So after we've done the correlations, let's go back to our race. Okay, until here, you realize that you have created so many workbook, but you don't see it, right? Actually, where it's stored is actually under the workbook section. When you click a workbook, then you can have a one view, like all the canvas or all the dashboard that you have built earlier, right? So in this lab, we're going to use back the race analysis. Like, just go back to race analysis. Okay. So right now, what we want to look at is we want to look at only the Brazil race. Okay, forget about the worst race. We want to focus on the best one. Right. So how can we identify the comeback? So there's a hints given, like we focus on the Sebastian Wastel, right? Right. Let me make it bigger, right? So let's click on this guy. Yes, here. So you see, like, although this guy in the race, although this guy doesn't win anything, right? But eventually, for me, the performance is quite good because this guy is starting at the last place. But at the lap 8, he managed to make it on the position number 6 and fall back. And then after that, at the end of the race, is maintained at the position number 6, right? So based on the patterns like this, I can conclude that these drivers actually is outperformed on that day. All right, it's a comeback score, right? So sometimes when we want to find a race based on the pattern, there's a lot of story that we can tell. Just we have to go and analyze on the data itself, right? So next thing we're going to analyze on the pit stop, right? So for us to do that, we can now we need to change to the race 2021 Austrian race, right? So first thing, go back to my race analytics. So if I want to unselect, I just unselect that. Let's find the 2021. So let's look at this race, right? So now I want to look at the pit stop of the race, right? So in my data, I have a pit stop attributes here, right? So very simple, I just drag and put it here. So eventually you see my data, my plot have changed some shape, right? So for the round is no pit stop, but for the square actually is at the pit stop, right? So after we've done that, then we'll focus on, we can inspect the result. Okay, so you see the who is this, Alonso? Who's this guy? Or Norris? Okay, let's focus on Norris race. You see Norris, his starting position is at number 2, right? Then after that, he been overtaken by Hamilton, right, at the lap 20th, right? Then after that, he went into the pit stop, but when he come out, he been overtaken again by Bottas, right? Then after that, that's the only pit stop that he go in, and then he will go to until the end. Okay, so now so from here we can also inspect whether this driver's been overtaken from the pit stop, and the overtake is the jamming. Like this, and like this is the jamming overtake, but this one is a pit stop, right? So that is another way how we inspect the race based on the pit stop. All right. So after we done this, the next thing what we do is that we're going to do some calculations. Okay, let's go back to the Brazil. Let's go back to Brazil. So the next thing we're going to do some simple calculations. All right. Okay. So first of all, we're going to add a new calculations. Then after that, we will use the median millisecond accumulate minus the millisecond accumulate. Then we will name it at the delta goes car. Right. This is how it's going to look like. Okay. So what we do is like, you see there's a calculations here, right? By default, it's nothing because we haven't created any calculations yet, right? So what we do is like we just right click at calculations, right? If you don't want to hassle, then you drag the firstly we drag the median milliseconds. This one. Okay, and then we minus out the milliseconds accumulated. And then we give it a name. Right. It's always a good habit like you validate your calculations before you save it, right? So that will save you some troubleshooting hassle. At least you know that your calculation is correct, right? So you just save it. So now we will need to create a new chart, right? So in this chart, we're going to select lab, driver reference, and followed by the calculation field, which is our new one, the delta to ghost car, right? So what we do is we select lab, driver reference, delta to ghost car with our control key on the keyboard, right click, select line chart. Right. So now we can see how the driver performs on the race. Okay. You see at the beginning of the race, everybody's starting equally. Then after that, some people go faster, some people go slower. And then at the point of the 39, everybody back to square and then start to spread again. Right. This ghost car concept is the comparison. Comparing how the driver perform, is it be above or below the medium, right? So it's for us to check like, it's also one of the way like for us to check like how's the drivers drive, what kind of speed the driver drive along the race. Okay, so that is another way for us to analyze the ghost car, right? All right, and then after we save the race. All right, so that's conclude our lab number 5. All right, so we have analyzed the comeback score. We have already analyzed that whether the pit stop affecting the positioning, and also we have analyzed the ghost car effect, right, by drivers. So we know that how they perform, whether it's above or below the average, right? Okay, that concludes our lab 5. So the last lab of the day. So now we will go back to our database again, right? This time we will going to use some of the machine learning capability here, right? So first thing, you will need to set up a machine learning users from the database itself. Yes. By default, when you created autonomous database, there are a couple of features that are available, right? One of the thing is the machine learning features. Yes, when you provision the autonomous data warehouse, there is a built-in machine learning functions that are available within the database itself. So you don't need to do additional things, right? So when we come to here, come to the service console here, right? We will need to go to administrations, and firstly, what we need to do now is we need to create a machine learning users. So we go to manage machine learning users. Okay, log in as your admin, right? Because admin is your power user to handle any activities within the autonomous database. All right. So right now, what you see is like currently we will have only one admin user currently allowed to access to machine learning user, but I know that I actually have other users in my database, just maybe they are not the machine learning users. So in order for me to plot those users out, I can select the show all users here. All right, so right now I can see, oh, my F1 user is here. Currently, F1 have no role, that's why they cannot access to the machine learning. Right, now question, how can I enable this F1 as a machine learning users? Right, very simple, you just click on here, right? So give it any emails, but if you don't see any emails here, you just give any emails account. So once you save it, these users will automatically granted the machine learning users, right? So I just save it. Okay, right now you will see like now my F1 user have been granted the developer rights, right? So what I need to do next is for me to access the machine learning, I will need to log out my admin user and I will log in as my F1 user. F1 password. Let's try again. Oh, right, not this one. My bad. Okay. So let's come back to here, the service hub. You go to developments. Okay. There is an Oracle machine learning user interface, right? You just click on that. Yes, this is where I supposed to log in my F1 users. So once you successfully log in, this is the first page you see in the machine learning users interface, right? So after here, let's go back to the instructions here. So we have done this, we have done this, we have done this. All right. Okay. In this machine learning functions, right? We can, let's say you have other machine learning environment in similar like this, right? Let's say I create another machine learning notebook in here. I can actually export it and share among the Oracle machine learning environment, right? So in this case, you will require to download the one of the machine learning notebook that already previously compiled by our developers. If you want to check the contents, you can actually have a look on the contents, right? This is how it looks like. It will be in a JSON format. So, but in this case, we'll need to download this JSON file. So what I can do is I can just right click, save link as, then eventually it will pop up for me to save as a JSON file. Again, save this file in any directory that you can remember, because later on we're going to use this. All right. Okay. So once you save, you come to this machine learning notebook. Right now, you will need to import the notebook that you have saved just now. All right. In order for us to do that, let's go to menus, notebooks. right? Currently, I already have one notebooks here. Okay, this is the one. If you don't have, let me delete this first to avoid redundancy. Right. So by default, you have nothing. Right. This is how you're supposed to see. So in order for us to import, then you just click import button here. Select the notebook. And then let us have a quick inspect on what is contained in this notebook. Today, if you are using autonomous data warehouse, right, you can actually enjoy the benefit of these notebooks. What this notebook does is it's a notebook that supports both SQL and Python, right? Zeppelin by default is supporting the Python notebook, but when we use with Oracle, right, eventually it will support the SQL script as well. So why we will need this step? Because this step actually will leverage some of the features of the SQL to amend the table in our database so that it can give us some table structures that we need for our ML use case later on, right? So that's why you see we can actually run the SQL in a notebook, and you also can running the Python in this notebook, so you can use it both together, right? So right now what we do is we need to run all the script within this notebook. So we can come here on the top here, run all paragraph, we just click it, okay. Eventually, give it some time for it to run. Okay, so we start running, finish. Yeah. Let's have a quick inspection. Finish. All right. Okay, so now all the script have finished execution, so we can proceed to our ML. So what else we offer in this Oracle ML is there's one function called AutoML, right? This is the automatic ML creations features. For us, we just need to plot in our data structures, then eventually the system is smart enough to decide what is the best model for my data structures. That will save a lot of data scientist time, because what the data science work at is to decide what is the best model for my data, and different data set can have a different models, right? So until here, so what we need to do is we need to create an ML models based on this. We will need to create an ML model based on auto ML functions, right? So for us to do that, let's come to auto ML here. We'll create a new experiment. So in the instruction, we'll give the experiment called predict race score, right? Predict race score. And then for the data source, that we will need to select the F1. And then F1 race trend. All right. Race trend here. Okay. So once you select the data set, then you will need to define what you want to predict. So the next instructions, we will need to predict the score, and the case ID will based on the race ID, right? So we go to the score race ID. So once you select the score, you will see the prediction type already been defined in the prediction type. So as you can see, when you select your data type and you select your predict target, right, the system actually is smart enough to decide what kind of predictions that you need and what kind of model that you will need also, right? these are the default models that selected. And for this case, we will use the negative mean square errors. Okay. All right. So next step is very important. We will need to select those that in need. All right. Okay. So in this case, like we don't need a name. We don't need a name here. And we don't need a couple of things. Okay. Let's proceed. Right. Why we need to take out some of the things like your name and name. Okay. Remember when we do MLs, right? Name is not important, right? We need to find the key drive that affecting the ML model, right? But name is not the one because name is always unique. So that's why when we do the ML training, we won't consider all the unique columns like IDs, like your personal IDs, your name, that which will identify who you are. We try to take that out. So now what we do is like we want to take those that are needed columns, right? So eventually I know that I don't need the name, I don't need the overtake total, I don't need race ID and race ID count. Okay. So I don't need overtake, I don't need also. I don't need time URL weathers. Okay. Times URLs weathers. Well, but I need weather web. Yeah. And I don't need the year and year C. All right. So sometimes this step is quite important because we want to eliminate the overfit errors, right? So if you overfit your data, sometimes they might create some bias. All right. So after we've done it, we can save first. And then we can start. Okay, before you start, right, you can have two options. Firstly, you'll get a faster result, but maybe you will compromise some of the accuracy, right? But if you want the more accuracy model, you can always choose the accuracy, but then you will need to compromise the speed of creating the models, right? So because of the interest of time, we will use the faster result. So once you click that, the system will start to evaluate on all the models based on your data set, right? So it will give you some time to run. So now as you can see, your model is start running already. So in the split second, you can see the result of each model, right? Right. So you can see the score of the result have been coming in. So bear in mind that we are using the negative mean square errors. What it means is like the smaller the negative value will give a higher accuracy of the models. So by the end of the result, we're going to choose one of the best model for our dataset use case. Right. So I think pretty much done. It's a final fine tune now. Okay. Okay. Now we should have our result, right? So in this case, okay, now the ML study is completed, right? It took about a minute, right? So how can I choose the model, right? Like I say, currently we are looking at the negative mean square error, right? So what it means, like the smaller negative value will give me the higher accuracy of the model. So in this case, based on what my result or my data, it give me that support vector machine that actually will give me a better result, right? Which is, this is the number SVMG. Then remember this number. Okay, why we need to remember this? Because the next thing what we're going to do is that we're going to plot this model into our cloud analytics cloud. All right. Okay. First of all, I will need to register the ML model here. So what you can see now, by default, my in my machine learning currently they have no machine learning, right? So now I need to register one, which is I want to register this in my analytics cloud. So for me to do that, I can click on the page menu here. There is a register ML models features. All right. So I click register ML models. Then I will need to select connections. So eventually, these are all the models I have been gone through along the way, right? So just now, let's check what model that we want. We want this VASG SVMG C6676, right? So I come here, I clarify FVNG C6. This is the one that I want, right? I create this, then I click register. So once I register, immediately you can see like this ML is available in my machine learning here, right. Next thing, what I need to do. Next thing, what I need to do is I need to create a data flow. Right now we are at here, right, at the analytics. I need to create a data flow. All right, before that, I need to, okay, remember just now when we run the notebook, actually there are some update in the data set also. So before I do my data flow, I will need to go back to my home, click on data, select, sorry, I need to click on the menus and click open the data set, because I need to update the data set. There are some changes in the data set after I running my ML's step, right? From here, I can click edit definitions. Okay. Now, what I see is like there are more fields that currently available in my race dataset. All right. So for me to select, for me to update, I just add all here. And if I want to check, I can refresh the data a bit. Yeah. So now my data is updated, right? And I click save and OK. All right, so let's go back to the instruction. Next thing, what I need to do is I need to create a data flow. I already have registered. So next thing, what I need to do is I need to create a data flow. All right. So let me quickly brief what this data flow will do. All right. So when I create data flow. Okay. Sometimes in a lot of analytics project, we can't avoid that. We need to do some sort of data transformation, or we might need to do some combination between the two data sets, right? So data flow is a built-in features available in the Oracle Analytics Cloud that allow you to do all sort of transformation, including applying ML, right? So that's why now what we need to do is that we need to select the race data. Let's double check. Let's select the race data, right? Select the race data. Secondly, we will need to filter the data only on the years 2020 for our ML, right? So either we can drag the filter here, or we can add the button. Then there's a filter options here, right? Once it's here, okay, then we need to tell the system what we need to filter. We need to filter based on year, right? Yes, years only for 2020. Okay. And then what happens next? Next thing, I need to apply the machine learnings, right? So again, I can use the plus button here. I click apply model. So eventually I can select the model that I've just registered in just now, right? So I just click OK. Yep. So these are ML options. So I will create, based on after the ML, I'm creating a new model called predictions. Okay, and then the last step of the ML. So last step, I need to filter out the column. I only need 4 columns, which is the race ID, username, score, and predictions. All right. So I can select columns. Okay. If I were to save my time, then I can just remove all. Okay. I need race ID. I can double click. Okay. And the next thing what I need is the name year. Name year, score, and predictions. Score and prediction. Yeah. Right. These are the 4 columns that I need. So after I've done it, I will need to save the data into the table and give you a name prediction score, right? Okay, let me copy the name first. Right. Okay, so and after that, I save the data. Okay. Score. Prediction score. Okay, and then I need to trace the race ID as the attributes. Right. Table name is event. So after that, I save. And I give you a name. So once I say, if I check everything is okay, I can start running the data flow. So eventually what it does is like it actually load the data from the race and then it put in the ML model, and then after that filter out some columns, and it will save the entire trends data into a new data set called predicted score. All right. So this is one of the use case for the data flow that available in the Oracle Analytics Cloud. All right. Right, when you saw this means your data flow have been successfully executed, and then your new data set should be appearing in here, predicted score, right? So now the last thing of the lab that we will need to create visualizations based on this predicted score, because we want to know that how accurate our predictions comparing the actual figures, right? So what we do is like we click on the predicted score here. Eventually open a new workbook here, right? So all we need to do is like I will highlight everything, then I will right click and use as a line chart. Okay, so just right click a visualizations line chart. Okay, is there something what I want? Let me check. No, eventually it's not what I want. I need to put the score and the prediction in the Y, and the X is remaining as a race ID and the name here, right? So what I do is like, okay, predictions, I will put in the here, race ID and your name, I put, yep, here. Okay, this is the race that I want. Okay, last step, I want to calculate the difference or I want to calculate the gap between my predictions and the score, right? So eventually, again, I create a new calculations, right? So what I do is like go back to here, I create a new calculations. So I will use a function called ABS. And then from here, I will drag, let's see, check the instructions. Prediction minus the score, all right? So I will drag my predictions here. minus out the score here. Then I give it name distance. Okay, save. So after that, I will pull my here in. So now I have this, but it's not good enough. If I let's say I want to present it in the new way, I want to in the other form, right? So what I can do is like I can select distance as a bar. So eventually now I can have both bar and line in my chart, right? So until here, what we see now so far is we know that the ML will predict some scoring and there's some actual score return, right? So let's say you create the Abu Dhabi, the gap is like about 1 point something close to 2, but there are some race that eventually you can predict quite close, which is this race, right? Eiffel, right? So now we have concluded our labs today that we managed to, based on the historical, we managed to produce some of the predictions of the fan score, how it's going to look like, right? And then finally, we will save the entire file. We'll save it as, maybe I can give you a name, predictions. Right, save. So that is all the labs for the sections today. All right. Okay, so let me quickly wrap up. So what we have just go through is like we go through the loading data part, right? So we go through the basic analysis and also advanced, and we have seen the advanced analysis on the overtake and etc. And finally, we are going through how can we use the Oracle machine learning available on the autonomous database to do some quick machine learnings here, right? So this is our labs today. So if you want to have more hands-on lab about Red Bull, feel free to drop by at this URL. So we will consistently update if there's a new events or new hands-on lab about Red Bulls here. All right. That's all I want to say today. Thanks for your time.
Thank you so much. Matthew. Excellent presentation as always, and I'm sure the people will enjoy. I have a few questions regarding the link to do the tasks, and I received that by the chat and by Charles, and I shared that with the people in Facebook. Also, they asked by the code to don't have the credit card requested, and I found that one. I share here in the chat, and I share with the people on the Facebook too. That means if you have any other questions, the people watching also the replay can ask us at the organization or contact Charles directly as per his contact information he showed in the presentations. Thank you so much, Charles, Matthew,
You're welcome.
Charles.
Thank you, Francisco, for
and
bringing
Chelsea.
us. Yeah. Hope to see you guys soon. Okay. Hey.
See you guys soon, and take care and be safe.
All right.
Bye-bye.
Bye.
Thank you. Bye.
CloudDB, shaping your new normal.